Welcome back! In this video we're going to go through some examples of doing derivatives that involve natural log. So let's jump in. First I want us to find two derivatives. They look similar but they're going to have slightly different results. So let's find the derivative with respect to x of 6 ln x and the derivative with respect to x of ln of 6x. So here the 6 is either on the outside, the constant's outside the natural log, or it's inside the natural log. So to take the derivative of 6 times the natural log of x, that 6 is just a constant, so I can factor it out of the derivative with the constant multiple rule. And then I'm just taking the derivative of natural log, which is 1 over x, so I have 6 times 1 over x, which I'll just rewrite as 6 over x. Okay, that's our whole derivative. Didn't take us too long. Next, let's do the derivative of natural log of 6x. There are actually two options for how you can do this. I'll show you both. So the first option uses properties of logarithms. So to take the derivative of the natural log of 6x, we're going to split that 6x over two logarithms. So when you have the log of two things multiplied together, you can split it up as the log of the first thing plus the log of the second thing. So here we can rewrite log of 6x as ln 6 plus ln x. And that's by a property of logarithms. So this method works well if you remember your logarithm properties. Then the derivative of the sum is just the sum of the derivatives. So I have the derivative of ln of 6 plus the derivative of natural log of x. Natural log of 6 is a constant, so its derivative is 0. Then I have the derivative of ln of x, which is just 1 over x. Okay, so derivative of ln of 6x is 1 over x. Kind of interesting that the derivative of ln of x and the derivative of ln of 6x are the same. I think that's sort of cool. So what's more likely is that you'll probably do the second method. You have to remember logarithm properties to help you out on the other method, which can be really useful sometimes to simplify things and make them easier, but we're not going to do anything too crazy complicated with logarithms, at least in these videos and examples, so you can probably just stick to this second method if you want. For this second method, we're going to use the chain rule. So I'm seeing that the inside function is 6x, and the outside function is ln of something, or ln of x. So the inside is g, the outside is f. I'm using that naming convention from the way we usually write the chain rule. Then we can just take their derivatives, since I know I'm going to need those. The derivative of 6x is 6, and the derivative of ln of x is 1 over x. Then, using the chain rule, the derivative of ln of 6x is f prime of g times g prime. Remember, that's the chain rule. I like to start with the g functions when I'm writing it out. So I have f prime of 6x times the derivative, which is 6. Then f prime is 1 over something, so I do 1 over 6x. That gets multiplied by the 6. The 6's cancel out, and I get 1 over x. So this second option, or second method for solving this particular example, ln of 6x, we got the same answer both ways. I think you're more likely to use the chain rule, but I just wanted to show that other option too in case that was more interesting to you. So this is a short and sweet one. We just did two examples using derivatives of natural log. Thanks so much for watching, and I will talk to you in the next one.